In the silent expanse of space, our radio telescopes are the giant ears we've built to listen to the cosmos. For decades, they've been tuned in, trying to catch the faint whispers of dying stars, the hum of new galaxies, and the leftover echoes from the universe's birth. We're cosmic eavesdroppers, listening for any stray sound in the infinite dark. But sometimes what we hear isn't a whisper. It's a shout. Imagine a single impossibly bright blast of radio waves, lasting for just 1,000th of a second. In that single moment, it unleashes as much energy as our own sun puts out in a full day. Now, picture that blast traveling for billions of years across the expanding void just to reach us. At first, scientists figured it had to be some of the most violent events known to physics. But then, it happened again, and again. And some of these signals have patterns so strange, so rhythmic, they challenge what we think we know about the universe, and they hint at something else, something unnatural, and maybe, just maybe, something intelligent. We're diving deep into the evidence, from cosmic accidents to the possibility of a deliberate message. If you love exploring the biggest questions in the cosmos, make sure to hit that like button and subscribe so you don't miss what we uncover. The Cosmic Scream, Fast Radio Bursts. The story of these cosmic puzzles begins, like so many do, completely by accident. Back in 2007, a graduate student named David Narkovich and his supervisor Duncan Lorimer were digging through old data from the Parkes Observatory in Australia. They found something that just shouldn't have been there. It was a signal of incredible power from 6 years earlier that had been written off as a simple glitch in the machine. But it wasn't a glitch. It was real. They named it the Lorimer Burst, and it was the first of its kind ever found. Today, we call them fast radio bursts, or FRBs. FRBs are one of the hottest mysteries in astronomy, and they're defined by 3 mind-boggling traits. First, they are incredibly short, lasting just a few milliseconds. A literal flash in the cosmic pan. Second, they are unbelievably powerful, capable of outshining entire galaxies in that brief instant. And third, they come from far, far away. Galaxies millions or even billions of light-years from us. Since that first discovery, we've detected thousands. At first, they all seem to be one-and-done events. A star explodes, a cataclysm happens, a single blast of energy shoots out, and that's it. This made them nearly impossible to study. How do you investigate something that's over before you can even point your telescopes at it? But then, in 2012, a discovery at the Arecibo Radio Telescope in Puerto Rico changed everything. They found an FRB that repeated. It wasn't a singular cosmic scream. It was a recurring shout from the exact same spot in the distant universe. This was a game changer. A repeating signal meant the source wasn't destroying itself. It had to be something that could stick around like a cosmic metronome ticking away in a galaxy far, far away. This discovery split FRBs into 2 groups, the non-repeaters, which are the vast majority, and the mysterious repeaters. This only made the puzzle deeper. Are we looking at 2 totally different phenomena? Or could all FRBs repeat, and we just haven't been lucky enough to catch them yet? The hunt for answers was on, and it would push our technology to the absolute limit. The Hunt for Answers, a cosmic detective story. Pinpointing a millisecond-long flash from a galaxy billions of light-years away is an insane technical challenge. It's like trying to spot a single flickering light bulb in a city on the other side of the country during a lightning storm. To pull it off, astronomers have built incredible machines designed to do nothing but catch these signals. One of the most important is CHIME, the Canadian Hydrogen Intensity Mapping Experiment. Located in British Columbia, CHIME looks like a row of giant metal half-pipes, and it scans a massive chunk of the sky every single day, making it a perfect FRB trapper. The secret to tracing these bursts is a phenomenon called dispersion. As radio waves travel across the near-empty space between galaxies, they move through a thin soup of plasma and gas. This intergalactic medium works like a prism for radio waves. Higher frequency waves travel faster, while lower frequency waves get slightly bogged down. So when a burst finally arrives at Earth, the high-frequency part of the signal gets here a split second before the low-frequency part. By measuring that tiny delay, astronomers can calculate exactly how much stuff the signal traveled through, which gives them a stunningly good estimate of how far it came. Using this trick and powerful telescopes, scientists started making breakthroughs. In early 2025, astronomers from MIT announced they had traced an event, FRB 2222-122a, not just to a galaxy, but to a specific spot inside it. They analyzed the signal's twinkle and determined it had to have come from a region just 10,000 kilometers away from a spinning neutron star. That's less than the distance from New York to Singapore. This was a smoking gun, placing the burst's origin right in the middle of one of the most extreme environments imaginable. The evidence was piling up, and it was all pointing to one prime suspect. Cosmic lighthouses or alien handshakes? The theories. When you're dealing with this much power, the list of things that could cause it is short and violent. For years, the leading suspect behind fast radio bursts has been a celestial monster known as a magnetar. A magnetar is a special kind of neutron star, which is the super-dense core left over after a massive star collapses. But a magnetar is a neutron star on a whole other level. Picture the mass of our sun squeezed into a ball the size of a city. Now, give that ball the most powerful magnetic field in the known universe. A field so strong it could wipe a credit card from halfway to the moon. The leading theory is that FRBs are caused by starquakes. The magnetar's insane magnetic and gravitational forces cause the star's crust to crack, which unleashes a colossal burst of energy from its magnetosphere. This theory got a huge boost when astronomers spotted a weaker FRB coming from a known magnetar inside our own Milky Way. For the first time, we caught the culprit right in our own backyard. More evidence for natural causes came when scientists solved the mystery of another repeating radio signal. This one was traced to a cosmic couple, a dead white dwarf star and a red dwarf companion locked in a tight 2-hour orbit. As they dance around each other, their magnetic fields clash, creating predictable radio blasts. This was a huge discovery because it proved that the universe has more than one way to make repeating signals, adding another suspect to the natural lineup. It really seemed like science was on the verge of cracking this case wide open. But the universe is almost never that simple. For every signal we think we can explain, there's another one that just breaks all the rules. What if a signal is too perfect, too specific, too structured? This is where the conversation shifts from astrophysics to one of the biggest questions we can possibly ask. Are we alone? The search for alien technosignatures is a real scientific field, and for decades it's been fueled by some tantalizing but ultimately unproven whispers from the cosmos. The most legendary of these is the WOW signal. In 1977, the Big Ear radio telescope picked up a powerful 72-second-long signal. It was so unusual that the astronomer who found it, Jerry Amon, just circled it on the data printout and wrote next to it. It came from a patch of sky with nothing of known interest, and it looked exactly like what you'd expect from an alien broadcast. And then it vanished. It has never been heard from again, leaving it as one of science's greatest unsolved mysteries. While no FRB has been quite that wow, like the steady repeating nature of some is definitely eyebrow-raising. The clockwork precision of certain bursts makes you wonder. Are we just seeing a natural cosmic lighthouse spinning in a predictable way? Or could we be listening to the pulse of an alien engine, a navigational beacon for starships, or even a deliberate interstellar hello? The vast majority of scientists agree that a natural cause is by far the most likely answer. But good science also demands that we keep an open mind. We have to follow the evidence, and sometimes that evidence leads us to some very, very strange places. The signals that break the rules. Just when the magnetar theory was starting to feel comfortable, new discoveries threw a wrench into the whole thing. In early 2025, astronomers were stunned when they traced a repeating FRB named FRB 2409a to a place it had no right to be, the outskirts of an 11.3 billion-year-old elliptical galaxy. This is a dead galaxy where star formation stopped billions of years ago. That's a huge problem for the magnetar theory, since magnetars are supposed to be born from young, massive stars. Finding one in a galactic retirement home is like finding a newborn baby in a city where no one is under 80. It just doesn't add up. Then there are the discoveries that defy all our categories. Using Australia's ASCAP telescope, astronomers found something they call odd radio circles, or ORCs. These are gigantic, ghostly rings of radio light. hundreds of thousands of light years across, often with a galaxy right in the middle. They are completely invisible in other wavelengths of light. One leading theory is that they're the shock waves from a massive burst of star formation that happened long ago, but no one knows for sure. They're just these enormous, silent, glowing rings hanging in space, and it gets even weirder. Astronomers found an object called GPM J1839-10 that sends out radio pulses every 22 minutes, an incredibly slow beat that defies our models for pulsars and magnetars, which should have shut down long before spinning that slowly. Incredibly, after finding it, they checked archival data and realized it's been pulsing away since at least 1988, hiding in plain sight. At the same time, we're getting better at spotting the fakes. In 2024, a signal that initially baffled scientists was traced to a defunct NASA satellite from the 1960s, a piece of zombie tech still tumbling through orbit. Other famous mysteries have been traced to something as simple as a microwave oven in a telescope's break room. This is the hard reality of the search. It's a slow process of elimination, and 99.9% of the time, there's a perfectly normal explanation. But it's that other 0.1% that keeps us listening. It's the signals from dead galaxies, the giant radio rings, and the impossibly slow pulsars. It's the nagging possibility that one day one of these signals won't be a magnetar or a glitch or a microwave. It'll be the real thing. The universe is broadcasting, and we're just now really learning how to listen. The mysteries are getting deeper, and the discoveries are coming faster than ever. If you want to keep exploring the biggest questions in the cosmos, make sure you hit that subscribe button and turn on notifications so you don't miss what we find next. So now we have to ask you, what do you think is causing these truly bizarre signals? Are they the wild, chaotic, but ultimately natural fireworks of exotic stars? Or are we finally hearing the first hints that someone else is out there in the dark? Let us know your theory in the comments below. We live in an incredible time for discovery. We've gone from finding a single, lonely burst to cataloging thousands of them. We've found a prime suspect, the magnetar, and even caught one in the act in our own cosmic backyard. We've solved puzzles like the pulses from binary stars, which proves our methods are working. And yet, for every answer we find, the universe asks two new questions. We find FRBs in ancient galaxies where they shouldn't exist. We find giant, glowing radio circles that challenge our imagination. We are constantly reminded that our neat little theories are just a rough first draft of the full story. The cosmos is more creative, more violent, and far stranger than we can imagine. We haven't found a confirmed alien signal. Not yet. The evidence for extraterrestrial intelligence is still zero. But the search has barely begun. Our telescopes get more powerful every year, and our ability to decode the symphony of space grows with them. For now, we remain cosmic eavesdroppers, our ears pressed to the wall of the infinite. We're listening for the whispers, the shouts, and the faint, rhythmic patterns in the static, waiting for the one signal that could change everything.